Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0571, indicates a malfunction in the brake pedal position switch circuit of the Honda Accord models built between 2017 and 2023. This code is categorized under the Powertrain Control Module Fuel Injection PGM-FI systems. The brake pedal position switch is critical for confirming whether the brake pedal is engaged or released, which directly influences brake light operation and various safety features like cruise control. If this switch fails or displays erratic behavior, it can lead to improper brake light operation and potentially unsafe driving conditions. This DTC is typically set when the brake pedal is lightly pressed for 5 minutes or more, while the accelerator pedal is also depressed, creating an electrical fault within the circuit connected to the switch. Therefore, addressing this issue promptly is essential to ensure vehicle safety and compliance with regulations regarding brake light performance. The main component affected by DTC P0571 is the brake pedal position switch. This switch is located directly adjacent to the brake pedal within the vehicle's footwell area. Its primary role is to relay the status of the brake pedal, whether it is pressed or released, to various vehicle systems. This information is crucial for activating the brake lights, which must illuminate whenever the brake pedal is engaged. Additionally, the switch impacts the cruise control system, ensuring that it disengages when the brakes are applied for safety. Issues with this switch can hinder normal braking function and create confusion for drivers and other road users. Regular inspection and maintenance of the brake pedal position switch are critical for overall vehicle safety. Several factors can lead to the setting of DTC P0571. The most common cause is a faulty brake pedal position switch, which may fail to send adequate signals when the brake pedal is pressed or released. Another potential cause could be an open circuit in the stop SW line that connects the switch to the Powertrain Control Module, PCM, thereby interrupting communication. Additionally, a blown fuse, specifically fuse A9, could prevent power from reaching the brake pedal position switch, leading to malfunction. Poor connections or loose terminals at either the brake pedal position switch or the PCM can also create intermittent signal failures. Properly diagnosing each of these possibilities is crucial to accurately resolve the DTC. The symptoms associated with DTC P0571 can vary in severity, but typically include malfunctioning brake lights, which may fail to illuminate when the brake pedal is pressed, or may stay on continuously without pedal engagement. This can not only cause confusion to other road users, but also fails to comply with safety regulations. Additionally, cruise control might exhibit problems. For instance, it may not engage or disengage properly when the brake is applied, leading to unsafe driving conditions. Finally, inconsistent signaling can occur, where the vehicle's computer may fail to detect that the brakes have been pressed, potentially resulting in erratic behavior by the vehicle when it attempts to interpret driver inputs. Being aware of these symptoms is crucial for effective diagnosis and repair. The first step in troubleshooting DTC P0571 involves checking the brake lights without pressing the brake pedal. This initial check is essential for determining whether the brake lights are remaining illuminated unnecessarily, indicating a circuit issue. If the brake lights stay on in this scenario, this may confirm an existing problem with the circuit that needs further investigation. If the brake lights do not stay on, this directs you to the next step, implying that the initial conditions of the circuit are likely correct. Understanding this step helps narrow down the problem effectively. ensuring that technicians can focus on specific components and wiring that stand to be tested further. Proper execution of this step lays the foundation for all subsequent checks. In the second troubleshooting step, the inspection continues by checking the brake lights with the brake pedal pressed. This test is critical because it assesses whether the brake pedal position switch is functioning correctly when engaged. If the brake lights illuminate as expected, this suggests that the switch is potentially operating correctly in that position. However, if the brake lights do not engage when the pedal is pressed, it indicates a failure within the brake light system or the switch itself. Thus, confirming the operation conditions of the brake switch leads you to the next steps, where further testing of the switch and its connections will be needed. This systematic approach ensures that any underlying issues are accurately pinpointed. The third troubleshooting step involves checking the brake pedal position switch signal. To perform this test, the vehicle must be switched to on mode, while the HDS, or Honda Diagnostic System, is used to monitor the parameters. You should look for a change in signal from on to off when the brake pedal is pressed and released. A clear change in status indicates that the switch is functioning correctly at that moment, even though intermittent failures may still occur. If there is no change in signal, this likely points toward a malfunction within the switch itself or its connections. It's important to check for possible loose connections or damaged wiring at this point. Additionally, if an onboard snapshot of the DTC is available from prior data, it should be used to reproduce the conditions of the fault for a more thorough diagnosis. In the fourth step of troubleshooting, an open wire check is performed focusing on the stop SW line. This is executed after disconnecting the necessary connectors and jumping the SCS line with the HDS. The voltage is then measured between the specified test points while ensuring the vehicle is in off lock mode and the brake pedal is pressed. If battery voltage is present, the stop SW wire is confirmed to be intact, which assures that part of the circuit is functioning properly. If voltage is absent, it indicates an open circuit between the brake pedal position switch and the PCM. Addressing this issue often requires inspecting the wiring thoroughly for any breaks or faults. Utilizing accurate measurements in this step is crucial to pinpointing circuit failures. Step 5 requires a direct examination of the brake pedal position switch to ensure it operates effectively. The switch's operational status can be assessed through testing its integrity. A functional switch should reflect a consistent and reliable response when the brake pedal is engaged. If the switch is found to be defective and fails its tests, it must be replaced to restore proper function. If it performs adequately, this guides the technician to pursue other potential underlying issues elsewhere in the brake light circuit. Understanding the switch's role and confirming its operational integrity is vital to the troubleshooting process and supports ongoing investigation into other circuit components that could be contributing to the DTC. In the sixth troubleshooting step, you will check the condition of fuse A9. This fuse is pertinent to the brake pedal position switch's circuit and essential for its operation. Without a functioning fuse, several electronic systems, including the brake lights, may not operate as intended. If the fuse is found to be blown, it needs to be replaced immediately, and further investigation should be undertaken to identify possible causes of the short circuit that caused the fuse to fail. Alternatively, if the fuse is intact, it suggests that power is being delivered to the switch as it should be. Each check at this stage is fundamental to ensuring that the circuit remains unobstructed and capable of performing its intended functions. The seventh troubleshooting step involves another open wire check, but this time focusing on the +B stop line. This test, executed under the same vehicle off conditions, measures voltage between the specified test points to determine if electricity is reaching the brake pedal position switch from the fuse. Should battery voltage be present at the switch, it signals that the circuit is intact, allowing for normal operation. Conversely, if voltage is lacking, an open circuit within this wiring is indicated, which would require tracing and repair to restore functionality. Identifying the status of the +B stop wire is crucial for diagnosing potential electronic failures in the circuit, ensuring all connections and components are functioning properly. The 8th troubleshooting step revisits the open wire check for the stop SW line. This further verification step is executed after disconnecting the necessary connectors and simulating an SCS short using the HDS. Following the same procedure as before, technicians will measure the voltage at specified test points while keeping the brake pedal pressed. If voltage is confirmed, it indicates that the wiring for the stop SW line is functioning correctly, saving additional time in identifying the source of the problem. However, if voltage is missing, it points out that there is likely an open in the wiring, necessitating further investigation and repair. Properly following this protocol ensures that technicians can accurately diagnose any remaining issues related to the DTC. In this step, the installation of the brake pedal position switch is examined to ensure proper engagement and adjustment. By removing the switch while keeping it connected, you will press its rod to see if the brake lights deactivate promptly. If the brake lights do not turn off when they should, this indicates an installation issue with the switch height or alignment, which may cause it to remain engaged unintentionally. Correcting the installation ensures that the switch can accurately reflect the position of the brake pedal at all times. Conversely, if the lights extinguish as they should, this confirms that the installation is proper, and the next diagnostic steps can explore other circuits or components for faults. Correct installation is crucial for the switch to fulfill its intended function. The final troubleshooting step involves a comprehensive check of the brake pedal position switch once again. This step confirms whether the switch is functioning appropriately after previous tests have been conducted. If the switch operates normally, this suggests that the prior issues may have stemmed from other parts of the circuit. If it is indeed malfunctioning, the switch must be replaced to restore full functionality of the brake light system and related systems. Ensuring the switch is operational helps finalize the troubleshooting process for the DTC. A proper functioning switch concludes the diagnostic cycle, paving the way for potential preventive measures in the future. After repairs have been made for DTC P0571, a final verification of the system is essential. This involves testing to ensure that the brake light system is operational and that no diagnostic trouble codes, DTCs, remain present. Utilizing the Honda Diagnostic System HDS to recheck for any active or pending codes helps confirm that the issue has been resolved. Completing this verification establishes certainty that all related systems are functioning appropriately and that the vehicle's safety features, including brake lights and cruise control, operate correctly. This final step is critical before returning the vehicle to the owner, ensuring peace of mind regarding vehicle safety integrity. Confirming completed repairs can also help promote customer satisfaction and confidence in vehicle reliability. For ongoing reliability and performance of the brake pedal position switch and related systems, preventive maintenance is essential. Regular inspection of the entire brake system, including the switch, wiring, and connectors, can help detect early signs of wear and damage. Additionally, routine checks of fuses and electrical connections can prevent potential faults from escalating into more significant issues. Monitoring for electrical faults or warning lights can ensure timely interventions before they lead to operational failures. Maintaining a proactive approach can help maximize the vehicle's safety and functionality over time, keeping it in optimal condition. Engaging in preventive care also extends the lifespan of the components involved in the brake system. In summary, understanding DTC P0571 is crucial for maintaining the functionality of the brake pedal position switch and related systems in the Honda Accord models from 2017 to 2023. Identifying the symptoms early allows for timely intervention, ensuring the safety of both the vehicle and its occupants. Following a systematic troubleshooting approach helps isolate and rectify issues efficiently, facilitating prompt repairs and minimizing downtime. Regular maintenance practices play an integral role in preventing future occurrences of this DTC, ensuring long-term operational integrity. Ultimately, these efforts converge to enhance the overall driving experience, emphasizing the significance of effective vehicle management. The key takeaway is the importance of an informed and diligent approach to vehicle maintenance and troubleshooting. Please like and subscribe to the channel. See you next time.